Hi everyone, my name is Akash. Today I'm going to talk about a little library that I've built called RocketRPC. It's good to see that we've filled most seats today, and it's good to have a tight-knit community because we can get to know each other individually. So yeah, it's nice to have this crowd here today. So yeah, before I start with the meat of my talk, I just wanted to give a little context on what RocketRPC is, how it was built, things like that. So yeah, context. The idea for RocketRPC started out all the way in 2020. Me and a few friends during the COVID period were thinking of building a restaurant ordering app where you would go into a restaurant, use a QR code to scan it, and then instead of you having to speak with a waiter, they just bring the food to you when you pay it online. So what you see everywhere nowadays. So we started along building it. We started with the user-facing pages first. So basically like a ordering type app where you would have different screens and components, each hypothetically having their own API. So for example, if you wanted to display a list of all of the items in a restaurant, you would make an API call. If you wanted to get an item's details, you would make another API call. And I mean, of course, if we were building an application for restaurants, we needed to build an admin dashboard for them as well. So this is an example from the internet, but this is sort of what we built. So we had an admin dashboard which comes with another set of APIs with itself. But what's the common connecting theme when we were building this application, whenever you're building an application? Yeah, connecting thread. It's all CRUD in the end. So whenever you're building something, whenever you're building APIs, you're mostly dealing with CRUD. You aren't doing anything too complicated with it. And that's what we realized as well. So how do we avoid this mess of APIs? In 2020, we had sort of two solutions. One is using hosted platforms like Supabase or Firebase. But the cons of them were that we would have to write very framework specific code. So how many of you guys have used Supabase or Firebase? How many of you continued to use it after a while? Not many do, because you don't really enjoy working within someone else's developer ergonomics. That was the case with us as well. Now there's serverless functions. We know there's always a server in the end of serverless functions. And unfortunately, if you have used these kinds of services like Next.js, Edge functions or Netlify functions or Lambda, they all run in AWS Lambda in the end. It's still sort of like API code. You're still reading the request object. You're still writing to the response object. So it doesn't really get you away from the APIs, and it's vendor lock-in again because you're locked into whatever vendor you're running with. So today I'm going to talk about this solution called RocketRPC. It's built using TypeScript, hence the title, destroying client-server barriers with TypeScript. And yeah, my name is Akash. I'm a software engineer at SigTech. We are hiring, by the way, so reach out to me if you want to look for a new role. And you can have a look at my website, thewriting.dev as well. And yeah, enough talk. Let's actually get into the meat of how it works and what it looks like. So we are going to look at a very simple application today, basically a to-dos app, the best way to experiment with anything. And let me go into the app. Sorry, I was working till late last night to make this work because it was just breaking. I've done this demo tons of times, but it was breaking the one time that I want to do it in front of an audience. So yeah, this is what we are looking at. I'll try to clear the console there. Yeah, just a normal to-dos app. You can add a few to-dos in here, and then you can check them, uncheck them, remove them from the list, whatever. However, the basic to-dos example. What does the code look like? I have created a simple to-dos component here, so we don't really have to worry about how it looks internally. It takes in notes here. It exposes a few callbacks, so like add note to add a note, on done. So what happens when someone says that a note is done? What happens when they actually delete it? And then a notes object here. It's a simple use state to handle notes. So just giving you an idea of what the client side looks like. Now, the server side, this is where it starts to get interesting. So this is what a server in RocketRPC actually looks like. In short, it's basically an API object that you expose to the client, and any method and object that you define inside of this API object is automatically exposed to the client. You don't really have to change anything else. And here comes the TypeScript part. Because of TypeScript, I can use type inferences and all of the other magic, we'll talk about that soon, to expose this type to the front end, and then you get all of the benefits like type completion and every other thing, which we'll have a look at as well. This is basically the RocketRPC server. You just pass in any HTTP module or a port number to it, your API object, and then the server options. So in this case, I'm just opening up the cores to everything, so I can access these objects from a React app. So yeah, we just had a look at the React app. Now we'll try to add some cool bits to it via RocketRPC. So firstly, let me access my RocketRPC client here using Use Client. This is just a simple hook that I created which deals with like, whoops, that's my timeout. I should actually close that in case it pops up again. Sorry. So yeah, this just accepts port number. So I have my Prisma server running on port 8080, I think. Yeah, 8080 here. So I just pass in HTTP localhost 8080, which connects the client to the server. And now is when we start to do interesting things. So right now we just have hello world here, again the most basic API that you can think of whenever you start a new writing in a new programming language or a new framework. So let's just call that console log that value right now. So console log, let's say client, and of course the magic happens when I press the dot operator on it, because it gives me type completions from everything on the back end. So here I have hello. I call that method, of course, because we defined it as a method here. And now if I go to my front end, initially it generates a promise, because since the RPC connects over a network, everything needs to be returned as a promise, and then it returns the result as hello world. And this is where the magic just begins, because we can start writing our own custom methods. So for example, if I want to write a method to sum two numbers, so num1, let's say number, num2, another number, and this returns num1 plus num2. And of course, TypeScript knows at this point that if you're summing two numbers and returning it, it's going to be a number. So if we try to deconstruct this, so const this is equal to client. And again, since this is completely running over TypeScript, this will just, this will give us auto completions here. And this sum, again, like we can call this method anywhere. So if I say console log sum 10, 20 or whatever, and then check that out here, then it will have that sum there. So okay, so we understand that we define a method in here, we access it on the front end. That's all right. So what else can this do? So I was talking about exposing objects before, and this is where sort of the cool part comes in. So I can actually expose my whole Prisma client via RocketRPC. So you can access Prisma from the front end, which is sort of exciting. I mean, if you're into security, it's not exciting. It's exciting in a different way, but yeah. For some reason, it doesn't give me auto completions for the Prisma client itself, but I'll just write that import down here quickly. And nice. So I exported a Prisma client, but what does it actually have right now? So I just have a simple to-do schema in my backend, which maps to the to-do object that I have created here, which is here. Yeah, this is to-do, which is just text string, status boolean, and ID string. I have to use an ID to uniquely identify each element in React, as we know. And oops, I think I opened a new thing, so it closed the whole thing. Yeah. So yeah, this is the model for to-do. It has the same structure, ID, status, text. Ideally, I should just have used this type while creating the to-do object there, but yeah, we'll get to that soon enough. And yeah, I've exposed this right now. So what I am going to do right now is try to change this application as much as I can, like just add persistence to it by accessing my Prisma client from the front end directly. And yeah, this is going to be fun. So of course, type completions, by this point you know what's going to happen. We are going to get the Prisma client, all of its type completions here as well. That includes like all of the schemas that you have defined in prisma.schema as well, of course. And yeah, what's the first step? The first step is that we need to render our to-dos here. We have nodes, set nodes, to-do. So to handle effects, of course, on load, we use a use effect. And then what do? We use prisma.to-do.findMany. And then again, all of this is happening over the network. None of this computation actually takes place on the front end, and this is what RocketRPC is supposed to be about. You just expose your objects, and then the library takes care of everything. So because it's using the same type, I can just pass in the set nodes callback to .then, and it will automatically generate the initial set of nodes here. Obviously, this doesn't really do anything right now because we haven't set any data in the table yet. So we're going to start doing that now. So the first callback that we should probably fix is add node. So I can add nodes here, but this doesn't actually store the data to the Prisma DB yet. This just, yeah, it's just on the front end. So how do I add persistence here? I'll just add prisma.todo. Again, I feel like I'm doing this so many times. I can probably destructure on this here as well. So const todo is equal to Prisma, maybe. I don't know. You guys can tell me if this is safe to do. But yeah, probably do something like todo.create and then pass in the data here. So that would be the new node which we have here. So the old callback, it was just modifying the existing nodes object and then appending a new node at the end via the spread operator. Everyone does it this way nowadays because everyone's used to safety in arrays, immutability, sorry. But yeah, so we can create a new object. And so earlier, how I was generating the ID was by using the date object, which is a very hacky way of doing it. You could use UUIDs or whatever, I guess. But in this case, since we are using Prisma now, Prisma auto-generates IDs for us. So that's nice. I can just remove the ID part from here. And then inside of .then, I'll just do the same thing, new node. And then this can go in there. And why is this complaining? Let's ignore it for a bit. New node, yep. That does it. So now let's try to add some new nodes in here. And if I refresh the page, it works. So yeah, we have persistence now via the Prisma layer. Thank you. And yeah, I'm just gonna continue to do this, but I guess you get the idea. Like I can use like todo.update here and todo.delete here, and then it will just use the same Prisma methods, exposing it over the client. And yeah, that's pretty much the functionality of RocketRPC. But there's a lot that you can do with it, to be honest, because one of the main things that I envision it in helping out with is sort of GraphQL resolvers or like a microservice architecture without actually writing any microservices. So you write servers which expose whatever method you want to write over RocketRPC. And like here, for example, this could be a Prisma client. A Prisma client which resides on a different server than your actual GraphQL resolver. And this resolver could connect to the DB through Prisma over the network and then return, to-dos or like do whatever you want to through the GraphQL resolver. Another thing you can do is also basic access other things. I mean, it doesn't just work with Prisma. It works with SQLize. It works with Mongoose, anything that you can think of, and expose those objects over the client as well. So I mean, I can define an API like this, like get users, user.findAll, whatever, and then use that within the resolver as well. So you get all of the benefits of working with multiple ORMs, and it's not just like different ORMs as in like SQLize and Prisma. It also covers certain what can I say, like cons of ORMs like Prisma as well. So for example, you know that you can't have multiple Prisma clients which are connecting to different databases within the same app. But here you can expose a different Prisma database from different servers and then use all of that within the same GraphQL resolver or within the same app. So you are not limited by whatever those applications can do either. And before I go to the next slide, there's also I mean, I've tried this with GPU.js as well. So for example, you can, if you're doing some complex calculation on the front end, you can offload all of that to the backend instead by just passing in the correct input types to GPU.js or whatever, and then making the computations on your node server or somewhere else. And yeah, I hope by the time you saw this, it was mind-blowing for you, and you might have the question, how does it work? So there's a few things going behind it, one of which is TypeScript, of course. We were just talking about how great TypeScript is. And yeah, let me go to the source code of RocketRPC to show you how that works. So basically, what am I using TypeScript for? TypeScript is providing all of the type inference here. So whenever we are exposing a type from the backend, wait, let me close a few things. So here, how I'm exposing this type API here. This is using all of the inferred types of the API object, and then you can use this as a generic on your client. So this is just an example client that I have here, but this is using the actual RocketRPC client. And what this does is it passes the type that you just exported from your server to the client generic. And so this is what results in all of the type completions that you're getting here, because it's just using the same type from the backend. And let me quickly go to the client and server here. Feel free to ask me any question about this at any point, because we are a small group. I think we can do like random Q&As as well. So where should I start from here, because there's a few things going on. I guess let's have a look at the server first. There's not really a lot going on in terms of TypeScript in the server. It's mostly socket IO, as you can see here, but we are going to get into that in a bit. I'm just trying to figure out, yeah, the server doesn't really have to worry about the types here. If we look at the client, it accepts a generic which can extend the record of string, symbol, or number, which is basically what a record accepts, everything a record accepts, and then unknown as the value, because we don't know what the value is going to be. And what do I do with this type? I run this through a custom type that I have written called promisify record, which is this complex thing which ChatGPT helped me write a little bit as well. And this basically adds promise. Return type extends promise of any, like it just adds promise to the return type wherever it is absent. And that's what gives you the correct like await types on the front end. And yeah, this is how TypeScript helps us, because the client proxy returns on, let me have a look at what this returns. Yeah, it basically returns promisify record of API. So we get the type inferences in the client as well. And what else does it work on? It works on object proxies. So object proxies are the fun bit. I feel like object proxies are quite underexplored. Prisma uses object proxies. TRPC, another library you might have heard of, it uses object proxies under the hood as well. And I am using it as well because they're really cool in what they do. So basically what they do is they allow you to create a fake object, and then it gives you certain traps on that object. So whenever a user is accessing a certain property or trying to call a certain method, then you can sort of execute your own custom code instead of returning whatever value that the user actually wanted to receive. So in this case, I'm using two traps for this object proxy. This syntax, this little syntax here, new proxy, and then a method inside of it. This is basically the initializer method, and then these are the traps that you can write for it. Yeah, this should just come from JavaScript. This isn't a custom library. And then the get and apply trap. What does the get trap do? The get trap allows you to trap on the dot operator. So whenever someone is using the dot operator, you can help them do something else instead. So how does this help me in this case? So in two ways, I have a special context called RocketRPC context where I expose certain values like what the current socket client is and a bunch of other things through with it. And if a user is traversing through a path, so for example, prisma.todo.findMany. So when a user is saying Prisma, what does that actually mean? So I have to generate that path and then send that to the backend. So I think it should be logged here as well. Yeah, so a path like this is generated based on what the user was selecting on the front end, and then it's passed to the backend for execution. And where is it actually passed to the backend? This happens on the apply trap. The apply trap is called whenever you're calling a method inside of an object proxy, on object proxy. So that is why it's sort of geared towards methods right now and not towards objects, RocketRPC, I mean. So when you're doing these things like calling basically calling a method on it, it sends it to, it traps on it on here on the apply trap. And object proxies are really fun because, using TypeScript, I can basically destructure it at any point. And when I'm calling the get or the path trap, whenever user is calling one of those operators, it actually generates that path correctly, even though you've destructured on it 10 times or whatever. TypeScript and JavaScript, they take care of everything. And yeah, so that's where object proxies come in. And right before I get into how this actually communicates with the backend, I'll tell you about the last part, that is socket.io. So for the network layer, I chose socket.io here because it is the most, I would say, reliable library to do server-side communication. It starts with WebSockets first because WebSockets are really fast, and there's benchmarks on it as well. And then if a client doesn't support WebSockets, then it falls back to HTTP long polling, which is basically it keeps on pinging the server for updates. And how am I using it? So on the client side, this bit is a bit complex because I'm using promise queues and things like that. If anyone has worked with multiple promises which resolve at random times, you know what a promise queue is, I guess. So initially, I just create a new socket, point it to my server, connect it, and then log like RocketRPC client connected so that the developer knows that it's now working. And whenever the apply trap is called, I generate an identifier to identify my unique function call within the promise queue, and then it generates a list of parameters that the backend uses, being the ID, what the path was, which procedure to call, the parameters, which parameters should I pass to it. And again, this isn't like science fiction code, I guess. This just comes from JavaScript, so I'm not even using any library. And then what I'm actually using the library for is socket.io. So I emit all of these parameters to the backend, and then what I do is I generate a new promise, which I then pass to the promise queue here, if I'm not mistaken. Wait for result, yeah. So it then generates, I guess this is more like a hash map, like a promise hash map, I guess. So it passes the promise, whatever the method call, with the ID that we just generated, and passes it to the queue. And how do I use this? So firstly, let's look at the queue object. It's basically like a mapping between a string and whatever method response that we were waiting for. And whenever the backend replies with a function response. What we do is we destructure a bunch of things from that result. So like the result, the ID, the status, the error, and this is all the error handling that I have right now. But I'm hoping to improve it, and maybe I get some contributors to help me with it, of course. And then I use the promise in this way. So key of ID of results. Since we were storing the resolve of the promise on the promise queue, so I can call it with the result, and then it shall return that result to the particular method which it was called from, and then I can delete it from the queue. On the back end, what this does is it just opens a new WebSocket for clients to connect to, and it waits for function call, and I think that's all it listens to. Yeah, that's all it listens to. So function call is all it listens to. Basically, it's a server which is responding to function calls from the client, and what it does is it generates the procedure path. I mean, basically procedure split is the path but separated. So if I'm passing prisma.todo.findMany, then I get prisma, todo, findMany, which I can then use to, you might have guessed by now, basically I can use it to, via square brackets, I can access the existing API object that I have, and then using that I can apply that function call on it. And since I get the parameters from my front end as well, I can just use this. So I can get to my procedure by iterating over the procedure path and then calling procedure params, and then I just return this result to the front end. And that's it. That's really how simple it is right now. Sometimes if you might get errors while you're building things, what I'm doing right now is pretty simple. I'm just printing those errors to the front end, like passing them over the network and just printing them to the front end instead. It could be better. I'm open for suggestions for this as well. And so yeah, that was my talk. If anyone wants to contribute to this, you could go to rocketrpc.com. If anyone wants to try this, you could try it out as well. It's good for inter-process communication, like client-server communication, anything that you can think of. And thank you. That was it. Yeah, before I forget, I'm at the writing dev on Twitter, or the writing.dev. Does anyone have any questions?
Hey, great talk. Why does it use WebSockets rather than HTTP for communication?
Yeah, I guess, there's advantages to both HTTP requests and WebSockets. So HTTP requests, the main advantage that they have is that you can cache on their responses. So if you were looking for like caching, I guess HTTP would be a better way to go for it. But in my case, I think Socket.io was a better solution because it allows you to send as many requests as you want over the network without really blocking anything. And also because you don't have to worry about batching and stuff. In HTTP, because the payload and response headers are so large, you might want to batch multiple requests together. So I don't really have to worry about anything like that over WebSockets.
Nice, thank you. Thank you for the talk. Because it uses Socket.io, so like if the data change from the server side, can it push the change to the front end?
Yeah, you mean sort of like server side events, right? Like passing data from the server to the client. Yeah, I guess you could do that. You could use Socket.io for it. You wouldn't really need a separate library for it then. I've been asked this before as well, but I'm not sure of a use case where you would want to pass some data from the server to the client. Maybe while you're streaming, maybe like subscriptions or something, I guess.
Or some dashboard, like when the data change kind of in real time, so you don't have to keep polling the server.
Yeah, that makes sense. Cool. Thank you.